Welcome to the first lesson of the Integer Properties module. Now, in a nutshell, the topic of integer properties is largely related to how the composition of an integer affects its characteristics and the way it behaves. One of the central themes of integer properties is divisibility. If x and y are integers, then we say that x is divisible by y if there is no remainder when x is divided by y. For example, 30 is divisible by 5 since 30 divided by 5 gives us a quotient of 6 with no remainder. Similarly, 12 is divisible by 3 since 12 divided by 3 is equal to 4 with no remainder. Conversely, 8 is not divisible by 5 since 8 divided by 5 is equal to 1 with remainder 3. Now, another way to define divisibility is to say that if x and y are integers, then x is divisible by y if there exists some integer k such that x is equal to k times y. For example, 16 is divisible by 2 since 16 can be expressed as 8 times 2, where 8 is an integer. Similarly, 18 is divisible by negative 3 since 18 can be expressed as negative 6 times negative 3, where negative 6 is an integer. Now, as an aside, it's important to note that although the concept of divisibility can be applied to all integers, we typically restrict divisibility questions to positive integers. Okay, moving along, one last example here. 40 is not divisible by 14 since there exists no integer k such that 40 is equal to 14 times k. All right, now let's examine some more definitions. If x is divisible by y, then we can say that y is a divisor of x. Or if x is divisible by y, we can say that y is a factor of x. The terms divisor and factor mean the same thing, so we'll use these two terms interchangeably. So we can say that 4 is a divisor of 8, or we can say that negative 10 is a factor of 40. Now, although negative 10 is indeed a factor of 40, you'll see that on the test, questions typically focus on positive divisors. Okay, one last example here. 15 is not a divisor of 20. All right, let's practice our knowledge of divisors. What are the positive divisors of 12? Well, these are the positive divisors of 12 since they all divide into 12 without leaving a remainder. You'll notice here that the positive divisors of 12 include 1 and 12. As you might imagine, every integer n will have 1 and n as positive divisors. Okay, moving along, the positive divisors of 9 are 1, 3, and 9. The next one's for you. What are the positive divisors of 60? Well, let's list them. Now, a useful way to avoid missing divisors is to list them in pairs. By pairs, I mean two integers that have a product of 60. So we'll begin with 1 and work our way up to 60. Since 1 times 60 equals 60, we know that 60 is another divisor. Working our way up, we should recognize that 2 is a divisor of 60. And since 30 combines with 2 to get a product of 60, we know that 30 is another divisor. The next divisor is 3, and it pairs with 20 to get a product of 60. Next we have 4 and its pair of 15. Then there's 5 and its pair 12. Now, as you can see, each number and its pair are getting closer and closer to one another. Once they meet, we'll know that we've found all of the divisors. Moving along, the next divisor of 60 is 6, and its pair is 10. At this point, we can see that there are still some numbers remaining between 6 and 10 that we have not checked. So let's check them. 7 is not a divisor of 60, and neither are 8 and 9. So our list is complete, and these are all of the positive divisors of 60. Okay, another important concept has to do with multiples. If x is divisible by y, then x is a multiple of y. For example, since 14 is divisible by 7, we can also say that 14 is a multiple of 7. Similarly, since negative 36 is divisible by 3, we can say that negative 36 is a multiple of 3. To expand on this, we can say that the multiples of 10 are as follows. Similarly, we can say that the multiples of 6 are shown here. Now, although these multiples include negative values as well as 0, you'll find that the test typically focuses on positive multiples. So far, we've seen several different ways to express the concept of divisibility. You'll soon find that your ability to solve integer properties questions will depend on your ability to recognize how various statements are all equivalent. For example, if x and y are integers, saying that x is divisible by y is exactly the same as saying when x is divided by y, the remainder is 0. Another way to say this is y is a divisor of x. Or we can say that y is a factor of x. Or we can say that x is equal to ky for some integer k. Or we can say that x is a multiple of y. All of these statements convey the exact same idea. So be sure to know all of the various ways to express the idea that one number is divisible by another number. Later in this module, we'll add even more statements to this list.